Hi there and welcome to this video for Senior Physics looking at quantum mechanics. In this video we're going to extend our knowledge of the cutoff voltage using the Phet Simulation. So if you go to this link, which you'll find on the iTunes U course, this will take you to a simulation that we've already looked at with the photoelectric cell. So basically what I'm going to do is I'm just going to open up that file now, and it's this one here. Okay, so basically what we've got, I've preset it on sodium, and I've put it on 204 nanometers. Basically this is a nice high voltage which is way beyond the threshold frequency for sodium. So basically what we're going to do is let's click up on this button here. This button will give us the current versus the battery voltage. Now basically what we're going to do is to look at what happens. Now we're going to add our intensity. We're going to put our intensity at about 50%, 50% there. Oh, almost there. There we go. So we've got 50% here. We've got a voltage around a wavelength of 204 nanometers. Now we can see that our electrons are flowing really well, and we've got a nice large current which is generated. Now how does the cutoff voltage work? Well, the cutoff voltage uses this battery here. Now you'll notice at the moment that the sodium plate here is being irradiated by the light, and it's liberating lots and lots of electrons, and they're generating a nice current of 0.803 microamps. So what happens is, with a cutoff voltage, I can work out the kinetic energy. Now remember, there's a certain amount of energy which is going to allow these electrons to be emitted. That's called the work function, and then what's left over is going to be calculated in the form of kinetic energy. Now remember that kinetic energy can be calculated by Q, the charge of the electron, times the cutoff voltage. So how do I determine the cutoff voltage? Well, what I'm going to do is I'm going to come down to this battery down here, and I'm going to push my electron. I'm going to change the terminals and push this slider to the left. And what you'll notice, as soon as I push this slider to the left, this then becomes negatively charged. Now you'll notice that negative charge starts to repel some of the very slow moving electrons. Now as I move the slider to the left, watch the current down the side here, and also watch what happens here. So basically what we get is, as I slowly move this slider, we begin to push away, and you can see the build-up of the negative charge here. And look what's happening. We've now got repulsion happening from this plate, and the electrons don't have enough kinetic energy. High energy electrons don't have enough kinetic energy to hit this plate. As a result, we've got a zero current. We're noticing here that we're getting 4 volts, and that's our cutoff voltage. Now if I go in the opposite direction, what will happen is an increase in voltage doesn't produce any increase in current. They're still all moving because the light intensity and the wavelength is such that only a certain number of electrons are going to be emitted. So I'm still getting a current of 0.803 microamps. Look at the curve that's been generated and relate that to the curve that I showed you in the previous video. Now obviously if I changed my light intensity, or I decreased my light intensity, watch what happens. I'm going to drop it down to 20%. So there we are. We've dropped it down to 20%, and I'm going to decrease my current, my voltage. Notice it's still an anode, and now I'm going to go in the opposite direction, and you'll notice that it doesn't take much to cause that repulsion to occur, but look at the voltage which is generated and prevents a zero current. We've got 4 volts here, and we've got 4 volts here. The only thing that's happened here is that basically the page has dropped. So let's just take a quick screen capture of that. We'll hold that there. We'll put this up to 50 again. We can see we've got zero current. We'll whack that one up, and then we'll take a screenshot of that, and you can see here that when we compare the two graphs, the two graphs, we get exactly the same shape, but by decreasing the intensity as we've got here, we lower the amount of current which is going to be generated, and that works for any type of metal that we've got. So I hope you found that useful. The idea there was just to show how we can change that cutoff voltage, and it allows us to work through different scenarios, but it gets you to see it working in action. Well, I hope you found that useful. Do join me again, and do check out some of the other courses present on my website, Aussie Physics. That's for chemistry and for physics. And thank you for watching, and I look forward to you joining me again. Bye for now.